Assalamualaikum warahmatullahi wabarakatuh and greeting. Today I would like to present my final year project with title Modeling and Simulation of Surface Roughness in Turning Process of D2 Steel Alloy using Artificial Neural Network ANN. My name is Muhammad Najib bin Ahmad Hasan. My matric number is 1893889. For the abstract of this final year project, this study discussed the effect of cutting parameter on the surface roughness on material that is difficult to cut, which is D2 steel alloy during turning process, and an artificial neural network model used for simulation, which is developed to predict surface roughness and cutting force with knowledge of the affecting parameters such as rotational speed, cutting depth, and feed rate. The ANN model consists of a feed-forward multilayer that is equipped by an algorithm for back propagation. ANN model show a fair agreement with the experimental finding, and this is therefore considered a reliable means of modeling and simulating the process of turning. So for introduction, the problem statement applying machine learning to machining process would result in a brand new process for this project that can help optimizing prediction for certain outcomes such as optimization of cutting method. Next is application of machine learning methods towards automation in the manufacturing process is essential to comply with the modern industry. So for this final year project, the objective is to apply machine learning for predicting the cutting force and surface roughness in machining, plus to optimize cutting force and surface roughness of D2 steel alloy material using turning process and ANN. So for the methodology, start with determining the project objective and problem identification. Next, we proceed with the background study and research journal, article, and books. Once understand the project, start with the literature review by selecting cutting parameters, select material and the equipment, and we have to design the experiment. Once the experiment have been done and the experiment have been conducted, the data collection will be used for the simulation, applying the machine learning on it. So from the result, once the result is relevant with the objective, we'll proceed with the discussion and conclusion, and finally presentation and final report. So for the result and discussion, the number of training is taken to be about 70% of the total data, while the number of tests is taken randomly to be about 30% of the total data. In fitting problem, need a neural network to map between a data set of numeric input and a set of numeric target. So as we can see in this table, it shows three tables. The number one is cutting parameter, number two is surface roughness, and the number three is cutting force. So for the application, this application can be obtained in the MATLAB, built-in MATLAB. So we can get an application and on the fitting neural network. So by inserting our input and our data target, we can proceed with, we can adjust for the training, validation, and testing the percentage of the involvement between of these three aspects. Next, we can adjust also the number of hidden neuron. This is depends on our modeling, because this can determine our position and how much our model going to the training process. So for the training network, we have three different kind of training: Levenberg-Marquardt, Bayesian regulation, and skill conjugated gradients. This one I will explain later. So once we have done for the simulation, the MATLAB will provide the solution for MATLAB function, MATLAB matrix only function, Simulink diagram, and also the neural network diagram. So for this one is the regression plot. As we can see, for the surface roughness for Levenberg, we can see a good, give an excellent regression coefficient. As we can see, the training is 0.99866. Same goes to the test, which is 0.962. For this regression coefficient, if the regression coefficient approaching to number one, it means the data was good. It means the output versus the target is good. As we can see, for the ring legend, shows data. The solid one shows the fit line, which is when the coefficient is going to be number 1, r equal to 1. And as we can see, the data, most of the data approaching on the line, fit line. Same goes to the scale conjugated gradient, which shows a pretty good distribution. As we can see, the data mostly approaching to the fit line. Same goes to the Bayesian, but it was a different story for the cutting force regression. For the Levenberg, shows a better compared to the other two. As we can see, the data distribution for Levenberg in cutting force regression, the data was scattered, but still approaching to the fit line. But compared to the cutting force for scale conjugated gradient training, as we can see, most of the data was away from the fit line. Same goes to the Bayesian. So therefore, I will use the Levenberg for comparison with the experimental data. So for the comparison between different training of regression analysis, the fastest one is the Levenberg, but it typically takes a great deal of memory. For the Bayesian regulation training, show better performance in terms of accuracy among the learning algorithm, where if there are several thousand of parameters in the neural network, we can use conjugated gradient to save memory. So for the comparison between predicted data by ANN experimental, as we can see, it shows a good comparison, which is the ANN, the prediction, and the experimental is close between each other. But for the comparison between predicted data by ANN and experimental data, we can see that for the ANN and the experimental data shows a significant difference from this. So we can use the predicted data to be applied for our next experiment, for further experiment. The effect of cutting parameter on the cutting force. The cutting force in machining is important because they are given the signature of machining mechanics. As we mentioned by Cameli and Norden in 2011, from the cutting force, it can identify the energy consumed and the power of machining used to turn process, tool, and the workpiece deflection. As we can say that higher workpiece hardness resulting in a higher cutting force used than the average in surface turning, in rough turning. So following finding is one on the basis of the analysis of investigation and the result obtained. The result revealed that the cutting speed and the feed rate have a significant impact on the lead to steel machinability. A rise of cutting speed has led to the reduction in the surface roughness of the hardened steel machine. D2 steel surface roughness is strongly affected by the feed rate. As the amount of the feed rate increase, the surface roughness decrease. That's all from me. Thank you.